Alright everybody, here goes a video on inverse functions, but this time we're going to work with them algebraically. So the important thing is to still remember what an inverse function is. Basically switching x and y. Now we know that f of x is technically y equals. So we could say that this is y equals 2x plus 5. So to find an inverse algebraically, all you have to do is switch the x and y again, and then solve for y. So we're just going to subtract 5 from both sides. That's going to give us x minus 5 is equal to 2y. And then divide both sides by 2, and you get x minus 5 over 2, or 1/2 x minus 5 halves. Either or, that is the correct answer for the inverse of f of x. That's it. All you have to do is switch x and y and solve for y again. So why don't you pause the video and try the next two. Just switch the f of x. Remember, f of x is technically your y. And then just switch x and y, solve for y again, and see what you come up with. Give them a try. So for this one, you should have x is equal to the cube root of y plus 2 minus 3. First thing you're going to need to do is add 3 to both sides to get the radical by itself. So you have x plus 3 is equal to the cube root of y plus 2. And then you need to get rid of the cube root by cubing both sides. And that's going to leave you with x plus 3 quantity cubed. We can just leave it like that. We don't have to multiply that all out. And then you just have to subtract your 2. So the inverse is equal to x plus 3 quantity cubed minus 2 after you subtract that 2 over. And that's it. And then for the next one, you should have again switched your x and y. And first thing you would have done was add the 2 over to the other side. And then you would have divided both sides by 4. Again, you can just leave it as x plus 2 over 4. And then you have to square root both sides. Now this part, I hope you're paying attention. Don't forget, whenever you're square root and you're solving, that includes solving for y here. You need a plus or minus. So you have the square root of x plus 2 all over the square root of 4, which we know is just 2. And that's equal to y. So the inverse is equal to plus or minus the square root of x plus 2 all over 2. Okay? So that's it. That's all you have to do to find an inverse algebraically. Just switch x and y and find y again. The last thing is verifying inverses. So to verify an inverse, what you're going to do is find the composition of functions. I know what you probably want to do is just find the inverse of f of x and see if it matches g of x, but that's not how you verify. To verify inverses, you need to take f of g of x and then also you're going to take g of f of x. So you're going to do the composition both ways. And if they both equal x, then they are inverses. If they don't equal x, then they are not inverses. Okay? So let's just show you how to do one. So we have f of g of x. So that means g is going into f. So, like we talked about this before, we're just going to put parentheses where our x is supposed to be and write the rest of the function. And then we're going to put g inside those parentheses. And then work it out. Distribute your 3. So you get x minus 6 plus 6. And those cancel. So you get x. So it works the first way. Now we're going to do it the other way. we're going to put f inside of g. So we have 1/3, and then there's our room for x, minus 2. And we're going to substitute in our f of x, which is 3x plus 6, and work it out. Distribute the 1/3, and you get x plus 2 minus 2, which also is x. So yes, they are inverses. Okay, that's it. So why don't you go right ahead and quickly pause, and you try the next one. Okay, so if you did f of g of x first, that means you put g inside of f. So that's going to give you x squared. So it's the square root of x plus 4, quantity squared, plus 4. And that's going to make that go away. You have x plus 4 plus 4. So you have x plus 8. And you already get to say, no, they're not inverses, because x plus 8 is not x. So all you have to do is find the composition, and both ways need to give you x for it to be inverses. All right, that's it for this video on inverse functions algebraically. This is Longo, and I'm out. See you, bye.